Another one is HISMELT process. So, these if you look at this, certainly the COREX process is a commercialized one and many plants are operating. Phoenix process on verge of commercialization, one commercial plant, one is there at the moment, but some other is also coming up soon. Beside these two, there is no other process has the commercial plant. Now, HISMELT is a promising one. This is started by CRA Australia long time ago, and then Germany and USA also joined later on in the development of it. So, this is again also based on the fines iron ore and coal. So, pre-reduction up to FeO in fluidized bed, melting in a melter gasifier converter type process, uses fine iron ore and coal, and a pilot scale plant is there. And this HISMELT, they have a pilot scale plant in Australia in Quina, but this also technology has been now taken by Tata Steel and others, and they are putting a sort of a new version of the process called HISMELT process, which uses cyclone converter furnace and having a pilot plant at Tata Steel Jubaindian. So, both the process have a quite a lot similarity, because this is the upgraded version of it, which is using a cyclone converter furnace, which was used in one of the smelting reduction process, but it is not commercialized yet. So, in HISMELT process you have this converter type of reactor, as we mentioned about it. So, you fed with the coal, and of course, the gases also goes into sorry, the air with oxygen actually it comes into this, and hot methane sludge comes out. The off gases which are coming out from the converter, this goes for the preheater of the to preheat the iron ore and limestone, and then goes to the cyclone. So, most of the reduction up to FeO stage it occurs into this, and these fines later on are fed into the converter. So, in this one post combustion is post combustion occurs, and it is a very integral part of the process. And so, this is a sort of flow diagram of HISMELT, and similar type of you can say for HISMELT, but it has a cyclone converter furnace, but still they are in development sort of stage, not commercialized yet. So, in brief, if you look at the overview of new iron making technologies and their output, this figure summarizes in a very good way. So, conceptual and laboratory stage, this electrolysis process VSS came, and the process which has come up to the pilot and development stage, HISMELT which we talked, raw melt, high cube, or smelt, Tenerex, and all this. So, the process which are related to these are smelting reduction and blast furnace related. So, they produce the hot metals, and the process in the bottom one are related to DRI or HPI or sponge iron. This produce the solid iron. So, these two curves are representing different things, hot metal and solid iron. So, in the hot metal one is melting reduction AISI American one, DIOS, CCF. These are the processes, and fine smelt on the other end for DRI, Sidcomet, VSA, Denerex. These are there, but now really none of these sort of in the operation. The yellow one shows these are coal based, and blue one shows the natural gas, and in this one the black one shows the coke, using the coke into it, and yellow one shows the coal uses. So some of these processes have been discontinued. The red marks, mostly red and green sort of idea, or discontinued. So commercial level and the growth stage, these are the process which came, which has a very high potential, high smelters, Hisuna, TMK3, Japanese one, Primus, Oxycup, and of course there was an iron carbide first, but discontinued, Finmet, and RSF. These are the processes which are more on growing stage and at the verge of commercialization. However, COREX and FINEX, they are commercialized process. Mini blast furnace is operated in many of the countries. Again, the advantage of this mini blast furnace is like smelting reduction process, or DRI, which we said when you need a small investment and localized demand to meet, you need a small processes, and in the same way the mini blast furnaces were developed, and they also work in many countries. They are in existence, especially in Brazil, China, India. Then quite mature stage, the process which have reached are modern blast furnace, and blast furnace in 80s. Those are the one which have reached to quite a matured stage now. And then you have a SL, RN, Midrex, and HYL. These again are all commercial matured processes which are there. And so this summarizes most of these processes. So this is already matured one, these are commercialized one, many of them, and some are on the verge of commercialization. And so some of these processes may lead to direct steel making, hopefully. So this about the alternative route of iron making, and we will talk a little bit about the energy and environment related issues in integrated steel plant. So I will touch upon briefly on these one, because this is also a small part of this course and one should understand about it. With the growing global warming problem which is happening, so we also have the responsibility to understand about the energy and environmental related issues which integrated steel plants are facing, and we should probably contribute in reducing it. So okay, we will start with the energy consumption in steel production by various routes. Now there are quite a lot always arguments that blast furnace is quite energy intensive. If you look at this table, so production step process: blast furnace, basic oxygen furnace to make the steel. Smelting reduction, you get the hot metal, basic oxygen furnace. DRI, where you have a solid iron, melting it in electric arc furnace. So by that route you make the steel making. Another is you already have the scrap and melting it in electric arc furnace and making steels. So these are the four routes. So this is anyway, because it is just involving the already scrap into electric melting it. So, it does not take care of that scrap formation how it arrived. So, certainly it would be having a very low energy. So, material preparation like in blast furnace you do the sintering. So, and coking coal you use it. So, you can see it takes about 3.3 gigajoule per metric ton of steel, and then blast furnace takes about 12.4, quite high. And in steel making, in fact, you get some energy back, so minus 0.3. Refining, you give it, so total is comes about 15.8 gigajoule per metric ton of steel. The other hand, when you use the smelting reduction approach to produce steel, so pelletization, it takes some of these, and then smelting reduction, it takes very high this iron very high energy. Of course, some goes back in steel making. Refining, some you have to use it. So, it is about 18.8 gigajoule, and if we go with DRI and electric arc furnace, so solid iron, so that again some other operation that take almost 3 gigajoule per metric ton of steel, and in reducing of it, it takes 9.2, and then melting of it, which is about 5.9, so 18.1. So, if you look at these main 3 routes of steel making, blast furnace BOF rule is still very competitive and takes quite low this energy. So, still we have not addressed the issue related to energy in this way, and that is one of the reason also these processes, though they are into existence since long, are unable to compete with the blast furnace BOF route. So, this gives you sort of summary of the various routes of steel making and how much energy is used in these various processes. Now, we look ahead. So, it seems there is no real possibility that we could do without steel. It is very true. At the moment, no other material is available which can replace steel in near future. Major iron and steel making processes, blast furnace, BOF, EOF, continuous casting, etc. are quite mature now and have little room left to improvements. New methods will be needed based on fundamental, technical, economical and ecological sound principle. Ecological sound principle is involved in that. And these because so much energy is used and most of the reduction is coming through coal in one way or another. So, which is producing the greenhouse gases, and that is where the global warming thing is coming. So, average global temperature, it is predicted by mid of this century may rise to 3 degrees Celsius. And there is a sort of a prediction of iron making route by 2050 that blast furnace still would be dominating, maybe about 60%. DRI natural gas route reduction may increase, may go to 25%, smelting may go up to 15%, and new one process looks promising, electrolysis may go to 1%. So, by electrolysis efforts are being done to produce iron, but this would be possible only if electricity is generated by other way, not using the coal, or in a clean way, it can be generated in a renewable way or like that. So, lots of talk about the greenhouse gases emission by the steel industries. So, I would like you to know what does it mean. We talked more about it. So, a greenhouse gas is a gas that absorbs and emits infrared energy. The primary greenhouse gases in the Earth's atmosphere are water vapor, carbon dioxide, methane, nitrous oxide and ozone. You know already the ozone layer is there around the Earth, and that is the one actually which is keeping us a bit warm. So, it absorbs and emits sun. So, these gases do not allow the infrared heat emitted by the Earth's surface to leave the atmosphere, thus creating a greenhouse effect and temperature rise. Without these gases, the average temperature of the Earth's surface would be somewhere like this. So, ozone is playing a very important role in that. Now, because if these other gases also come into picture, so temperature certainly is going to rise, and that is where the greenhouse effect is coming into picture, and we produce lots of carbon dioxide in integrated steel plant. So, the largest human contribution has been the emission of greenhouse gases known as anthropogenic emissions. So, emissions which are created by humans usually termed as anthropogenic emission. So, these anthropogenic emissions are the major cause of the global warming problem being faced today. So, it is becoming increasingly important to reduce these emissions for a sustainable future. So, integrated steel plant emits large amount of carbon dioxide, accounting for about 5 to 7% of total anthropogenic CO2 emission. So, we are contributing quite a lot in this. Besides that, of course, power plant and manufacturing industry are doing, and but carbon dioxide is that is the major product which steel industries are sending it into the atmosphere. Beside, of course, a little bit this, but this is the major one, and that is why lot of efforts are being made to reduce this carbon dioxide emission in the steel plants. So, globally by mid of this century, a drastic reduction has to be done in greenhouse gas emission, and those who lag behind may perish. So, very stringent rules have been made, and recently the Paris Accord is there on the environment. So, if the industry do not follow this, they have to shut down, and in fact many of them are shutting down due to violation of this greenhouse gas emission rule. So, in future the most important emission in iron and steel industries would be CO2, dust, dioxin, NOx, nitrous oxide and mercury. In order to reduce CO2 and other emissions substantially in iron and steel industry, there are three possible routes: carbon capture and storage, use alternate reductant like hydrogen or natural gas. Natural gas still has the problem reforming and again getting a CO2, like hydrogen is possible one, or electrolytic process, which we just talked in the previous slide. If electricity is generated in a clean way, this is the important aspect of it. So, beside that, in fact, there is another possibility like COG, coke oven gas, and BOF gas. They have a to combine them, you can make a syngas, and by using the Fischer-Tropsch reaction you can convert it into the useful liquid product, hydrocarbon, petrol and like that. So, that way one can also again capture the CO2 or carbon essentially. So, this so lots of efforts worldwide are going on to reduce the CO2 in the steel plants, and there are various um, technologies which are being developed. So, this table shows a brief description of various ongoing CO2 breakthrough program in the world. So, there is one American one, AIC technology roadmap. So, in this one mostly that increase the energy efficiency, competitiveness in North American steel industry, improve the environment. So, that uses the suspension hydrogen reduction of iron oxide concentrate. So, mostly by hydrogen reduction and molten oxide electrolysis. There is a POSCO South Korean steel making giant CO2 breakthrough program they have, and under this they have a 6 project, and the aim of most of them is the CO2 absorption using ammonia solution, carbon lean FINEX process. So, bioslag utilization for restoration marine environment, hydrogen production using co-carbon gas and waste, iron ore reduction using hydrogen enriched syngas. We talked about this syngas, which can be a combination of COG and BOF gas, and you can produce the syngas and carbon lean FINEX process. Course 50, that again an ambitious program of Japanese government, and it is in many stage of that. So, by Iron and Steel Federation of Japan. So, development of innovative technology for solving global environment problem. So, scenario making for global warming mitigation, CO2 separation, capture and storage, CO2 fixation by plants and its effective use. So, first stage, they have many stages in this, because by 2050 the aim is to reduce 50% of that emission. So, various phases are there of this. One first phase is over and second phase is starting, which is more related to industrial trial. Cause, that is ultra low carbon dioxide steel making. European plan to reduce the emission. So, cooperative R&D initiative to research rapid CO2 emission reduction from steel production, including process science, engineering, economics, like that. So, in this one, top case recycling of blast furnace with CO2 capture and storage technique. Israna, this HISMELT with CO2 capture and storage technique, advanced direct reduction again with the capture technique, electrolysis, they are also trying to explore this. And the last one is by BlueScope Australia. So, BlueScope Steel of Australia, it is an Australian initiative to reduce the environmental problems. So, in that one, efficient use of natural resources, reduce, reuse, recycle of waste material to develop a energy efficient technology. So, currently in a summarized way, if I said, so it seems me that blast furnace BOF and smelting reduction combined with carbon capture will be uneconomical by mid of this century. So, hydrogen and electricity based process may have potential to grow unless a radical change in the technology occurs in terms of carbon capturing. So, this is some of the important aspect related to environment, especially with respect to iron and steel industry, and one should be aware of it. There are many challenges iron and steel industries are facing, and lots of research can be done experimentally and mathematically also in a modeling way. So, I hope you have enjoyed this course, and thank you for listening and taking this course.